Sometimes you believe the network is cabled in a certain way, whereas in reality it's cabled differently. So you may think that one device is connected to another device, but that's not actually how it's cabled. Cisco Discovery Protocol, or CDP, and the industry standard version, Link Layer Discovery Protocol, or LLDP, are protocols that run at layer 2 in the OSI model and allow you to discover how devices are connected to each other. This runs independently of protocols such as IP version 4 and IP version 6. CDP and LLDP are a great way to discover how devices are connected and allow you to verify documentation as well as create new documentation. CDP is Cisco proprietary and will typically only discover other Cisco devices. Please be aware that some vendors such as HPE do not send CDP messages but will receive CDP messages, and hence they can see which Cisco devices are connected directly to them, but the Cisco devices will not be able to see the switches and routers from other vendors such as HPE unless the Cisco devices are enabled for LLDP. CDP uses multicast frames, which I'll demonstrate in a moment, but once again doesn't rely on higher layer protocols. We'll start with a simple GNS3 topology, and then I'll show you a more complex one in a different video. In this GNS3 topology, I've got 3 Cisco routers. One of them is connected to a hub, which is bridged to my local area network, which will allow me to see physical devices in the network. Router 1 and Router 2 are configured with IP addresses on their Fast Ethernet 0 interfaces. Router 2 is using DHCP on this interface, but this network hasn't been configured. So let's see how that affects CDP. Firstly, on Router 1, show CDP neighbors. What you'll notice is it sees the directly connected neighbor Router 2, but no other neighbors. I can also use the details command to see detailed information about that neighboring router. You can see as an example the IP address of the neighbor, the platform, the capabilities. In other words, this supports routing, it supports switching, and it supports IGMP. IGMP is used in multicast applications. We can see the version of operating system that router is using. On Router 2, show CDP neighbors. This shows a lot more detail. We can see Router 1, once again, connected via Fast Ethernet 00. We can see it's a 3725 router. But in addition, we can see a Cisco Unified Communications Manager. This is a Linux server that runs the Cisco Unified Communications Manager software that's running within VMware and is using Ethernet 0 somewhere in the cloud here to connect back through the hub to Router 2. Now, CDP only shows you directly connected devices that are running CDP. So as an example, Router 1 doesn't see these devices because Router 1 is separated from them by Router 2. But CDP messages are sent through a hub and any other layer 2 switches in the topology that are not running CDP. So there are actually some Cisco switches in this cloud that connect Router 2 to some of these devices such as the IP phones, but those Cisco switches are not running CDP and hence are not seen in the topology. So be careful. CDP shows you directly connected devices that are running CDP. This hub, as an example, is not running CDP. It's a layer 1 device, so CDP messages are transparently sent through it to devices in the cloud, and they transparently send CDP messages back to Router 2. In addition, there are layer 2 Cisco switches. These are small business switches that are not running CDP, and they don't show up in the topology. These 2 phones, as an example, are powered by a Cisco switch. So CDP does show you directly connected neighbors. That would be the exam answer. In the real world, it's not as simple as that. But let's look at some details. So show CDP neighbors detail. We can see some information about the Cisco Unified Communications Manager server. You can see as an example that it's running on Linux. We can see a Cisco 3750 switch here. Scrolling down, we can see a Cisco IP phone. Notice it's a Cisco DX650. That's its IP address. We could, as an example, open up a web browser to that phone. In this case, the phone is supporting a web browser, so we can see details about the phone, including its telephone number. CDP is great for discovering devices on the network, but also is a security risk because you can discover the devices on the network. That may be good for you, but may be bad if you have a hacker or someone inquisitive to find out what you're running. So as an example, I can connect to the Cisco Communications Manager. And if I knew the username and password or hacked it, I could then discover other devices in the topology. So back on router 2, there's a CUCM. There's the 3750. Here's my Cisco phone, DX650. I can see as an example the power that's drawn by that phone. I can see the operating system that it's running. I can see which port it's using to connect back to router 2. So router 2 is using Fast Ethernet 01. That phone is using port 1. Here's another phone, Cisco 7970. Its port is 1. The local interface on the router is Fast Ethernet 01. Here's router 1. Its outgoing port is Fast Ethernet 00, and router 2's local interface is Fast Ethernet 00. In this case, the router can see itself because CDP messages are being looped back to the router in the cloud. But once again, show CDP neighbors. We can see the local interface that's receiving CDP messages, and we can see devices and their local interfaces used to connect back to this local router. Now, what about R3? It's not showing in the topology, and that's because the interface isn't up. This interface is shut down. So I'm going to no-shut that interface, but I'm not going to enable an IP address on the interface. So we'll enable this link, but configure no IP addresses. So interface F0/0, no shut. But that's all we've done. Show CDP neighbor. No neighbors are shown yet. It takes a while for CDP messages to be sent. You might have to wait 30 seconds before you see any CDP messages. But show IP interface brief will allow us to see the state of the interface. Fast Ethernet 00 is up on router 3. Router 3 is connected on Fast Ethernet 00 to router 1 on Fast Ethernet 01 to router 3. Router 3 is connected using Fast Ethernet 00 to router 2's Fast Ethernet interface 1/0. So show CDP neighbors. We can now see router 2. The reason why the domain is showing up is I've configured a domain name of cisco.com on router 2. So the local router's interface is Fast Ethernet 00, and the interface of router 2 is Fast Ethernet 1/0. But please be aware that there are no IP addresses configured on this router. So show run interface F0/0, show IP interface brief. What you'll see is no IP addresses are assigned to any interfaces on this router. But CDP still works because CDP does not rely on IP. Let's have a look at detail. So, on router 3, show CDP neighbor detail. We're seeing router 2. We're seeing its IP address. The local interface of router 3 is Fast Ethernet 00, and the interface used on router 2 is Fast Ethernet 1/0. The outgoing port is the port of the remote device in this output, which can be very confusing. But that's a basic example of CDP. In the next video, I'll do a Wireshark capture, and then in subsequent videos, we'll look at a more complex topology.